Welcome everyone to section 7.4, adding and subtracting radicals. In this section, we're going to talk about how we essentially combine like terms with radicals and how we simplify those terms. So let's go ahead and start with an example. Here we have 3 radical 2, 3 squared of 2, plus 4 radical 2. Okay, now one of the properties that we can use in order to manage and show how we can combine like terms with radicals is to factor out the common term. So as you can see here, this is the same thing as 3 times radical 2 and 4 times radical 2. They both have, well, first let me show you a different way. If this was 3x plus 4x, we could factor out an x for both and leave 3 plus 4 in the middle. Okay, so it's the same thing with 3 radical 2 and 4 radical 2, is we can factor out a radical 2, and then what's left is the 3 plus 4. So 3 plus 4. Now what we can do is we simplify, and this is equal to radical 2, and I'm going to put the 7 out in front now. 7 times radical 2. And that's your answer, 7 radical 2. Most people write it without the little dot or multiplication symbol in between. Okay, so only radicals with the same radicand can be combined. So the number here underneath the radical is the radicand. So only the number with the same radicals can be combined. This is similar to like terms. So if you have x's and y's, you can only combine the x's with the x's and the y's with the y's. Okay, so 2x minus y plus 3x minus 4y would be equal to 3x minus 5y. In the same way, if we have 2 radical 2 minus radical 3 plus 3 radical 2 minus 4 radical 3, you only can combine the radical 2's together if we're writing in terms of radicals, 5 radical 2, and then you only can write the y's together, so minus 5 radical 3, or the radical 3's together. So that's just an example of how we're thinking about this. So steps to solving, the first thing we're always going to do is we're going to simplify to lowest terms. Okay, so that's the first thing. So if you want to see how we do that, you can refer to other videos, but we cover that pretty extensively. So let's go ahead and do that here. I have 3 times, and I'm going to split this up. I know a perfect square that fits into 24 is 4. So I'm going to rewrite this as square root of 4 times radical 6. You could also use the factor tree method. And then I know that square root of 54 is the same thing as square root of 9 times the square root of 6. So now I'm going to multiply and reduce. So I have 3 times square root of 4 is 2, radical 6, plus radical 9 is 3, radical 6. Simplify further, 6 radical 6 plus 3 radical 6. They are like terms. They are the same radical. 9 radical 6 is your answer. Okay. Keep in mind that you can't do something like this. If we have radical 9 plus radical 16, you just can't combine underneath the radical. Okay. Now it so happens that this is 3 plus 4. Okay, which is not equal to 5, and that's why you can't say that these are equal, okay, because 3 plus 4 is not equal to 5. So that's why we can't combine radicals like that. They have to have the same radical. So let's go on to another example. This one is not a square root, so this is a good example for us to do. We have 2 with a cube root of 16 minus 5 times the cube root of 24. Same process. The first thing we're always going to do is simplify. I know a perfect cube is 8 times cube root of 2. That gives me 8 times 2 gives me 16, minus 5 times, and 8 again is a perfect cube that goes into 24 times cube root of 3. Let's simplify now. So I have 2 times 2 times cube root of 2 minus 5 times 2 times cube root of 3. That gives me 4 cube root of 2 minus 10 cube root of 3. Now, just because these are both cube roots does not mean we can combine them. Okay, they have to have the same radicand underneath. In this case, they do not. So what do? This is as much as we can simplify. Okay, if you want, maybe you could factor out a common term with the coefficients. So you could say 2 and then parentheses 2 cube root of 2 minus 5 cube root of 3. But really that doesn't do you much. Both of these answers are true, but you cannot combine the radical 2 and the radical 3. Okay, this one's a little bit more complicated, a little bit more simplification involved. Here we're back to square roots, and this one is a cube root. So first we're going to try to simplify this. We got 5 square root of 4 times cube root, or square root of x cubed, plus 3 times the cube root of 64 times the cube root of x to the 4th. I always like splitting up everything underneath the radical first. I think it makes it a little bit easier and organized, so you can keep things straight, and then it's not so overwhelming. Okay, so we're going to simplify. 5 times square root of 4 is 2. Now, I can split square root of x cubed into square root of x squared times square root of x. So that's going to give me x radical x plus 3, and now I need to think of the cube root of 64. I believe that is 4. 4 times 4 times 4 gives me 64. So that's times 4. And then I have the cube root of x to the 4th. So I'm going to split this guy up into the cube root of x cubed times the cube root of x. And I know that the cube root of x cubed is x cube root of x. I'm going to finally combine all my coefficients in the front to give 10x square root of x plus 12x cube root of x, and that is as simple as I can get it. So that is my answer. Moving on to the next example, we have fractions. It's not much more complicated, but it's something to be mindful of. So the first one, again, we have 10, and then I'm going to write this as cube root of 5 over the cube root of x to the 6 minus 3 times the cube root of 4 over the cube root of x to the 9th. Okay, let's start with the left side. So here we have the cube root of 5. We're not going to be able to simplify that, but we are going to be able to simplify this. The way I like to think of these is you could either write it as the cube root of x cubed times the cube root of x cubed. So that's going to be x times x, or x squared. Or what I like to do is write x to the 6, and then I raise it to the 1/3 power. I multiply the exponents because it is power raised to a power, and I get the same thing. I get x squared. So whatever way you prefer, roll with that way, but stay consistent and keep using a method that you're comfortable with. That's the most important part. So I have 10 times cube root of 5 over x squared. And I can extend this all the way over because if I multiply the 10 times the fraction, it's going to stay in the numerator. Minus, we have 3. Cube root of 4 cannot be simplified, so we're going to leave it. Over x to the 9th, this could be rewritten as x, the cube root of x cubed times cube root of x cubed if you wanted to. Or you can do what I like to do and do x to the 9th to the 1/3 power. You multiply power to a power. You multiply exponents to get x cubed. Okay, there's nothing more to do here. We have unlike radicals, and we even have unlike denominators. So we're going to go ahead and simplify, circle this as our answer as the most simplified. Last 3 examples. We can also use distributive property with multiplication with radicals and multiplying radicals together. So if I'm using the distributive property, I multiply the square root of 5 times both terms. 2 radical 5, I cannot combine them underneath the denominator, or excuse me, underneath the radical. But if I have square root of 5 times square root of 6, I can combine those underneath the same radical. It's not like addition. Addition, if it was square root of 5 plus square root of 6, that is not equal to the square root of 30. However, with multiplication, it is. Okay, so there is no way to simplify square root of 30, so this is our most simple answer here, like this. Let's move on. to the next example. Again, we're going to be using the distributive property. Okay, but before I distribute, I'm going to simplify first. So I have 4 times a radical 12. I know I can simplify this, and this is square root of 4 times the square root of 3. Sorry, that was an attempt at a 3. Here we go. Which is 2 radical 3. And I know square root of 27 is the same thing as square root of 9 times square root of 3 minus 3 square root of 3. So I'm going to simplify in the radical first, and it looks like I won't even have to distribute. So that's why it's always good to simplify first. It can save you some time. So you have 4 times minus 1 radical 3, or just negative radical 3. And I have negative 4 radical 3 after that multiplication. That's my answer. Okay, if you have a binomial, okay, binomial meaning 2 terms, multiplied by another binomial, 2 terms, then we can use FOIL or LOIF. Remember, this stands for first, outside, inside, last, but you don't have to necessarily go in that order. I will go in that order just because that's something I'm familiar with, but this is how I like to draw it, okay? I multiply the square root of 5 by both terms inside the second parentheses, and then later I'm going to multiply the 3 times both terms inside the second parentheses. So let me start with the square root of 5. Square root of 5 times square root of 6, we already showed that, but we can multiply those together all underneath the same radical. Plus square root of 5 times 1 is square root of 5. Moving on to purple. 3 times radical 6 is just 3 radical 6, plus 3 times 1 is just 3. I'm going to simplify now. So let's use blue. I have square root of 30 plus square root of 5 plus 3 radical 6 plus 3. I can't reduce square root of 30 because there's no perfect squares that fit into it. And these are all different radicals here, here, and here. So we can't combine them. So this is our final answer. I hope you guys found this video helpful, and I will see you next time when we talk about rationalizing the denominator.